When you want to use code from one Python file, you must import it, as we saw with the math library. For the additional modules that are built into Python, you do not need to worry about where it is located on your computer. For other Python files that are not built in, the simplest solution is to put the additional file in the same directory as the code that wants to import it. Here is the folder that contains the PyCharm project we see here. We'll take the graphics folder from my downloads project, copy it, and then we'll paste it into the folder where the PyCharm project is. I could also drag and drop it from one folder to the other. If we use import graphics, we need to put graphics dot in front of the type of the objects from the graphics module each time we construct one. This is a bit tedious, so there's an easier way. We can use from graphics import star, which brings in every type from the graphics module, so we don't need to write graphics dot each time we create an object. The downside to doing this is that it's more difficult to tell what code came from the graphics module. Also, if you had written your own class named point, circle, etc., you would have a naming conflict. This program shows some of the object types the graphics module contains. The common convention is that class names, which are the types of objects, are capitalized. Uppercase circle is the name of the class, and lowercase circle is a variable name. This convention allows us to easily determine which is a type and which is a variable by how it is capitalized. Note that the circle constructor requires two values. The first must be a point object, and the second must be a number. Also note that we save the point at 200, 200 in the variable center, since we wanted to use it for both the center of the circle and where the text should be centered. We did not save the other points we used to create the other objects, since we only used them once. We created the points and immediately sent them to the objects we were creating, rather than storing them in a variable since we didn't need them again. The graphics module has a class named GraphWin to represent a window on your screen. We can construct a GraphWin by sending it a string to use in the title bar of the window, and then the width and the height in pixels of the window. In case you weren't aware, pixel is short for picture element. Your computer screen consists of dots, each of which can have their own separate color. These dots are known as pixels. In this case, our window will be 400 pixels by 400 pixels. The win equals GraphWin statement creates a GraphWin object and stores it in the variable named win, which is short for window. Let's use the debugger to run it so we can see what happens as each line executes. The graphics window appeared and then was hidden when PyCharm stopped at the breakpoint. We can hide the sidebar by clicking here, and then resize the PyCharm window so we can see the graphics window. Or when writing your own graphics programs, move PyCharm away from the top left corner of the screen so you won't have this issue. You can make the list of files reappear by using the View Tool Windows Project option, or the keyboard shortcut Command 1 on the Mac. On Windows, I think the keyboard shortcut is Control 1. Pressing the keyboard shortcut again makes the sidebar disappear again. Next, we create a point at coordinate 200, 200. 0, 0 is the top left of the screen, so this will be in the middle of the screen. Note that the point does not appear in the window. Next, we'll create a circle object, which requires two pieces of information to construct. The first must be a point representing the center of the circle, and the second is a number representing the radius of the circle. We can then call the setFill method, which we can send a string. The common colors such as red, green, blue, and others will all work, but not every string is a valid color. The circle has still not shown up. To make any of the graphics objects appear on the screen, you call the draw method on that object. The draw method requires you to send a GraphWin object, indicating the window in which you want the object to appear. As we mentioned, the circle is centered at 200, 200, and because 0, 0 is at the top left of the screen, and the circle has radius 60, the top of the circle is at coordinate 200, 140. Next, we see the graphics module has a text object for displaying a string. To construct a text object, you send it the point where you want this text centered, and the string that you want to appear there. And then once you draw it, it appears in the window. A rectangle is constructed by sending it 2 points representing two diagonally opposite corners for the rectangle. We'll draw it now, and let's determine the coordinates. This is 60, 60, and this is 140, 140, so this is 60, 140, and this is 140, 60. A line is constructed by giving it the two endpoints. An oval is constructed similarly to a rectangle. The points represent the corners of the rectangle the oval will be contained in. Right here is about 40, 360, and this is about 360, 399. The GraphWin object has a getMouse method, which waits for the user to click the mouse. I always put this at the end of my graphics programs, so the window will remain on the screen so I can look at it. Once I click the mouse, the next line is executed, which closes the window, and then the program ends since there's no code below that. This program should give you a basic idea of how you can use many of the objects in the graphics module. The book has a reference section at the end of the chapter showing you the names and methods in each object and how to call them. The book does not make it clear exactly which type must be sent as parameters to the methods, but the names and examples should allow you to figure out which types you need to use.